You are currently the only person in this conference.
Good morning, students. Am I audible? Can you see the screen, Amma? Good morning, students. Can you see the screen? Am I audible? Okay. Sir, I will start the session in 2 minutes, Amma. Children, చూడు ఎక్కడికో. Sir, I will start in 2 minutes, Amma. Okay. दोनों है. दोनों है. Okay, students, see. Yesterday, see, when I talk about the post-tension, see, students, this is called, this we call it as ducts. Okay. In these ducts, what we are doing, we are introducing the tendons. In these ducts, what we are doing, we are introducing the tendons. And see, students, the space between the tendons is grouted. The space between the tendons and the duct is grouted. So here we'll discuss about grouting. We'll discuss about what they mean by grouting. We'll discuss about what they mean by grouting. So what they mean by grouting is whatever the cement paste, you consider any cement paste which is used for grouting should have the cement paste which is used for grouting. They can ask you, Amma, what is the cement paste used for grouting? The cement paste used for grouting should have a water cement ratio of 0.5. Okay. Whatever the grouting you are doing, The grouting should have the cement paste used in the grouting should have a water cement ratio of 0.5. Next, if we consider large ducts, for large ducts, if we consider for large ducts, the cement mortar with, or you can say cement mortar with cement mortar with cement mortar with fine sand, cement mortar with fine sand passing through cement mortar with fine sand passing through 150 micron is used. Cement mortar with fine sand passing through 150 micron passing through 150 micron is used. So what I would like to tell you students is whatever the sand you are using in this, sir, see, first point you have to see that water cement ratio is 0.5 and fine sand passing through which sieve they can ask you. The sieve is 150 micron. And remember students, whatever the compressive strength of, are you following students? The compressive strength of, if I talk about the, if I talk about the compressive strength of 100 cubes, suppose whatever the cement paste you are using, the compressive strength of 100 cubes, the compressive strength of 100 cubes of the grout should not be less than should not be less than 17 MPa, should not be less than 17 MPa at 7 days. Should not be less than what, sir? Should not be less than 17 MPa at 7 days. I hope you are clear. So he's telling 17 MPa at what, sir? 7 days. And see, first point we have discussed about water cement ratio 0.5. Second point, whatever the fine sand should pass through 150 micron. And the third one is the compressive strength of the cement. You can write the compressive strength of 100 cubes of the grout should not be less than 17 MPa. And now see the grouting pressure. Sir, usually what we'll do with pump it actually. So it should have, the grouting should have a pressure and the grouting pressure should not be less than 7, the grouting pressure should not be less than 0.7 MPa. Students, every point is an objective question. They can ask you in grouting what is the water cement ratio 0.5. In grouting, what is the cement mortar with what is passing through? Fine sand passing through 150 micron is used. The third point is the compressive strength of 100 cubes should not be less than 17 MPa. And the fourth point is grouting pressure should not be less than 0.7 MPa. Is this clear, students? So this is what we have to study related to the grouting pressure. Now see students, let us discuss the minimum reinforcement. What do you have to provide the minimum reinforcement in prestressed concrete? Next what we have to discuss is the minimum reinforcement. Okay. When I talk about the minimum reinforcement strengths in prestressed concrete, the first one we'll be talking is about the longitudinal reinforcement. How much should you provide the longitudinal reinforcement? You'll ask me how much you have to provide the longitudinal reinforcement. How much you have to provide the longitudinal reinforcement. When I talk about the longitudinal reinforcement, if you talk for my 0.2 percentile of gross area, 0.2 percentile of gross area for mild steel, 0.12 percentile of gross area for mild steel, and you have to see that 0.15 percentile of gross area for HYST bar, 0.15 percentile of gross area for HYST bar. Now immediately Rohit will ask me, sir, why it is more in mild steel? सर इधर माइल्ड स्टील का स्ट्रेंथ बहुत कम है, इसलिए इधर ज्यादा स्टील है. HYSD का स्ट्रेंथ थोड़ा ज्यादा है, इसलिए इधर एरिया इधर स्टील का स्टील यूसेज इज लेस. आर यू गेटिंग मी सर? इधर स्ट्रेंथ कम है सो ज्यादा है, इधर स्ट्रेंथ ज्यादा है सो कम है, ऐसा है. नेक्स्ट we also have to discuss about the traverse reinforcement, or you can say, when I talk about the members when they are subjected to dynamic loading, members with the dynamic loading in case of traverse reinforcement, when you talk about the members with the dynamic loading means a moving load. Suppose if a train is moving on that bridge, you see metro stations, bridges, all nowadays everything is done with prestressed concrete because the construction is very fast and all. So when I talk with the members with the dynamic loading, it should not be greater than it should not be greater than 0.3 percentile of gross area. Should not be greater than 0.3 gross area. If you see, this is for what, sir? All these for all transverse reinforcement. These we have discussed until longitudinal reinforcement. In transverse reinforcement, first ones we have to discuss is the members with the dynamic loading, and members with dynamic loading should not be greater than 0.3%. And if you talk about without dynamic loading, this is with the dynamic loading. And transverse reinforcement without dynamic loading, it should not be greater than 0.1% without dynamic loading. Without dynamic loading, it should not be greater than it should not be greater than 0.1 percentile of gross area. Sir, everything is an objective question here. Numbers with dynamic loading should not be greater than 0.3 percentile, and numbers without dynamic loading should not be greater than 0.1 percentile of gross area. Sir, see, when you talk about the deflections, when you talk about the deflection, the total deflection should not exceed the total deflection should not exceed the total deflection should not exceed span by 250. The total deflection should not exceed how much, sir? Span upon 250. And see, sir, deflections after erection. Deflection after erection means after erection means you are doing any support or anything. Deflection after erection. Deflection after erection should not be greater than span by 350. So all these are the codal specifications which are used for pre-stressed concrete. Is this clear for everyone, my dear students? Now let us go into the new topic, and which is also very important in a problematic point of view. Now see, the first one is the next topic I would like to tell you is the analysis of pre-stressed concrete. Next point I would like to discuss is the analysis of pre-stressed concrete. So see, in this analysis, first thing we are doing is assumptions. Sir, why do we assume some assumptions? We assume some assumptions to make the complex problem into a easier problem. To make the complex problem into easier problem, we will assume the assumptions. Okay. Now the first assumption is Now the first assumption we have is the term Shahid. Now see sir, when the first assumption here is the first is a concrete is a first assumption is a concrete is a concrete is a homogeneous. The first assumption is Concrete is a homogeneous. Concrete is what, sir? Concrete is a homogeneous elastic material. What is first one, sir? First one I would like to discuss here is the concrete is a homogeneous elastic material. So when I talk about the homogeneous elastic material, what do you mean by homogeneous? You can say concrete is a homogeneous elastic material. Same properties in same properties in homogeneous means same properties in same direction. Suppose if you consider material, the properties will be same in the same direction. If same properties in different direction, then it is thank you. Then it is known as isotropic. So what are the assumption is? What is the assumption is soil is homogeneous, elastic. Sorry, concrete is a homogeneous elastic material. Next, the next point I would like to tell you is within the range of within the range of working stress, within the range of you can write here within the range of working stress, within the range of working stress, within the range of working stress. Concrete and steel behave within the range of working stress. Concrete and steel behave within the range of working stress. What's that? Concrete and steel behave elastically within the range of working stress. Concrete and steel, how the concrete and steel will behave? Concrete and steel will behave elastically. That means why they are behaving elastically, sir? They are almost means here you can say the stress behavior of concrete and steel will be proportional. They also this statement says that the stress varies also linearly. This statement says that stress varies linearly. Within the range of working stress, concrete and steel behave elastically. Okay. The next point I would like to tell you is you should know Bernoulli's assumption. You should know the Bernoulli's assumption. What does this Bernoulli's assumption says is what does this Bernoulli's assumption says is sections sections which remain in plane section which remain in plane section which remain in plane before bending section which remain in plane before bending remain in the same plane remain in the same plane after bending. Sections which remain in the plane before bending remain in the same plane after bending. So what does this assumption says is what does this assumption says is sections which remain in plane before bending remain in the same plane after bending. So here you can say that Bernoulli's assumption says that Bernoulli's assumption says that strain varies linearly. What's that? Bernoulli's assumption says that strain varies So here what is the assumption is concrete is a homogeneous elastic material. Next, within the range of working stress, concrete and steel behave elastically. And the third assumption is sections which remain in plane before bending remain in the same plane after bending. This assumption says that strain varies linearly. This assumption says that strain varies linearly. Now, see students, let us move on to the analysis part. Let us move on to the analysis part. Okay. Now, if I talk about a concentric tendon, if I talk about a concentric tendon, sir, see, do you know what is a concentric tendon? If you talk about the concentric tendon, what is a concentric tendon, sir? So here, what is a concentric tendon means? Here you can write here, what is a concentric tendon means? A tendon which passes through the center. What is a tendon? A group of wires, or if you see, sir, see, this is how the thing. So it is passing through the neutral axis. So here, what will be the eccentricity? Zero. What is a concentric circle? A circle having same radii, but sorry, concrete having sorry, a circle having different radii with the same a circle having same center with different radii. So here, what is concentric tendon means? Eccentricity will be zero. In this case, stress will be taken as load upon area. In this case, stress will be taken as load upon area. And how will be the stress distribution? The stress distribution will be rectangular because it is uniform throughout the section. Sir, the important point I would like to tell you is whenever there is a concentric tendon, it passes through the. So, what does the concentric tendon means? It passes through the center, and the eccentricity will be zero, and the stress will be uniform, and the stress will be uniform. Now, let us see, students. Sir, this is the stress due to what, sir? You can say this is the stress due to load. Here there is a pre-stressing force piece, and we have a section. So here this stress is due to direct load. This is the stress due to direct load. Now, my dear students, I have a thing concept you might have studied in SOM. You know, M by I is equal to what, sir? You know, M by I is equal to F upon Y is equal to E upon R. So you can write here, students, M by I is equal to F by Y is equal to E by R. This is the very important formula. Now, when I talk about F, you can write F is equal to capital M into Y upon I. So this will be taken as sir. This will be taken as section modulus Z. So here bending stress can be taken as, sir, this will be taken as 1 by Z. Actually, Z is known as what, Amma? Section modulus. Z is known as section modulus. That is moment of inertia upon Z is equal to I by Y. Sir, what is Y bar? Distance from the neutral axis to the extreme fiber. So here you can write bending stress is equal to F upon M by Z. So this concept will be helpful in the next sir, see how it. Suppose if I consider a rectangular section here, and this is the neutral axis. Okay, now see students, and we have a beam here. Okay, and this is the neutral axis. And suppose there is a pre-stressing, there is a tendon here. There is a tendon here, and you will have a force here, pre-stressing force. And this is acting at an eccentricity E. If this is acting at an eccentricity E. Now see students, the stress distribution diagram for this will be uniform. One is P by A and P by A. Now see students, there is a pre-stressing force here. What is moment? Moment is nothing but what's a load into eccentricity. We can write PE, and bending stress can be written as PE upon ZB Z. So this can be written as, usually at top it will be compression. So if I see here, it will be, you can write here negative and positive. So if they ask you students, how is the stress distribution? So here it will be PE by ZT, that is section modulus at top, and this is low PE into ZB, section modulus at bottom. So if I talk here, what is the stress at top is P by A minus PE by ZT. What's that? It is the stress at top, and what is the stress at bottom is P by A plus PE upon ZB. Okay. So see students, what I would like to tell you here is whatever the stress at top is equal to what, sir? Stress at top is equal to P by A minus PE upon ZT, and whatever the stress at bottom is, whatever the stress at the bottom is, P by A plus PE upon ZB. So here what I would like to tell you is these are the stresses, sir. This is the stress at top and this is the stress at bottom. This is the stress at the clear, students. Now see students. So please remember they can ask you what is the stresses at top and bottom when there is an asymmetrical loading. So this is important among both top and bottom. Now see students, let us see if there is a dead load also. Suppose if you have a section here like this. If you have a section here and we have a pre-stressing force. Here we have a, this is the tendon. Suppose if I consider this as a tendon. And here you have a pre-stressing force. Here you have a pre-stressing force. So in this case, loading, and we also have one is dead load, and also we have the another one is live load. This is live load, this is dead load. So see students, if you see the stress distribution, it will be load by area. This is due to direct stress. This is the stress due to load. Next, if you see, you know already the stress due to some eccentricity. The stress due to eccentricity is PE by ZT minus plus PE by ZB. Now see students, if I talk here about the moment due to dead load. The moment due to dead load upon ZT. Sir, here because see, here there is a dead load and this load eccentricity, it will, the moment will act about, suppose if I taken like this, if I consider a load at this section, it will act in this way and it will act in this way. So these two will be opposite side. And if you talk about the due to live load also same, ML upon ZT and this is ML upon ZB. And here you can write MB upon ZB. So here if you see the resultant, how it will be there is, it will be somewhere like this. So what is the stress at top is, what is the stress at top? If you see here, the stress at top is P by A minus PE by ZT plus MD plus ML upon ZT. P by A minus PE by ZT plus MD plus ML upon ZT. Similarly, if I talk about the stress, this is the stress at top. And if I talk the stress at bottom, you can write here P by A plus PE by ZB minus MD plus ML upon ZB. Sir, you see here, I am writing. Are you clear, students? What is P here? P is nothing but the load. P is the load here, and E is the eccentricity. E is the eccentricity, and Z is nothing but the section modulus, that is I by Y, moment of inertia upon distance from the neutral axis. So Z is equal to section modulus. Z is equal to what, sir? Section. So here you can write load eccentricity Z is equal to I by Y. That is equal to section modulus. So here when I talk about the stress at top, the stress at top is given by P by A minus PE by ZT plus MD plus ML upon ZT. Or stress at bottom is P by A by PE by ZB minus MD plus ML upon ZT.
बी सर बेस में जेड के बेस में
Sir, ZB means section modulus at bottom. ZT means section modulus at top. ठीक है sir? Is it clear? Hello?
यस सर
Now, see students, I will tell you a small problem how this can be asked. So, how the question can be asked here is one second. The problem here is consider a rectangular beam. Consider a rectangular beam. Consider a rectangular beam. See, 1 second, students. Consider a rectangular beam. 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 150 into 300 mm. Consider a rectangular beam. 150 into 300 mm. Consider a rectangular beam. 150 into 300 mm is pre-stressed by. Consider a rectangular beam. 150 into 300 mm is pre-stressed by. Is pre-stressed by 4 high. Is pre-stressed by 4 high tensile wires of 4 high tensile bitu sound check. 4 high tensile wires of 5 mm dia 4 anti-tensile or 5 mm dia, 4 mm dia, pre-stressed to 120 MPa. The wires are located at an eccentricity of the wires are located at an eccentricity of 50 mm. The wires are located at 50 mm eccentricity. Calculate the sir, repeat. Which one you want me to repeat, sir? Sorry, moment. I have not seen that. Sir, see. Here, sir, see. First thing. Sir, here if there is, sir, same equation if you see, if you put eccentricity 0 and moment due to dead load and live load 0, you will get the stress due to direct load. If you put moment due to dead load and live load 0, you will get the stress load due to you will get the stress due to load and due to movement. But there is additional here, sir. Sir, I told you what is stress, Amma? Stress is nothing but load upon area. What is moment? I told you, sorry. What is bending stress? Bending stress is F is equal to M by Z. Here, what is the moment I have taken? Here it is nothing but P upon Z. That is bending stress. Similarly, you will have moment due to dead load. Sir, see here, moment due to dead load upon Z is bending stress, and here you are taking moment due to live load upon Z is the bending stress. So, did I answer your question, sir? Is it clear? Okay. Now see, sir. Sir, there is a consider rectangular beam. So he's asking calculate the calculate the stresses at the bottom. Calculate the stress at bottom. He's asking what is the stresses at bottom. Sir, see, you are clear. How is the stress at bottom, sir? If you see, only due to loading, it is P by A minus PE by Z. Or stress at bottom is P by A plus PE by Z. Now see, sir, what they have done, 4 high tensile wires of 5 mm dia is pre-stressed to a 120 MPa. So when I start the solution, he is asking what is the stress at bottom. So whatever the stress at bottom is equal to load by area plus PE by Z. Now to calculate load, how do you calculate load, sir? They have given stress. So pre-stressing force. Sir, if I see here, pre-stressing force should be calculated. So how do you calculate this pre-stressing force? This is nothing but stress is 120 MPa, stress into area. Area is how much, sir? 4 high tensile wires of 5 mm dia. So 4 number of pi by 4 into 5 square. So if you see this, you will get a value of around 9.42 into 10 power 3. You will get that is 9.42 kilonewton. Clear, students? So you will get a value of how much, sir? 9.42 kilonewton. Now see, the stress at bottom is given as, what is the load here? We have 9.42 into 10 power 3. And what is the area of the section? Area of the section is 150 into 300. So 150 into 300. Here also the load is 9.42 into 10 power 3. And what is the eccentricity, students? Eccentricity is nothing but 50 mm. Okay. Now how do you calculate Z here? How do you calculate Z is equal to what, sir? I by Y. So if you take moment of inertia of a rectangle, it is BD cube by 12. And the distance from the neutral axis to the extreme fiber is d by 2 in case of a rectangle. So this will be equal to how much, sir? Section modulus BD square upon 6. Okay, if I substitute here, B is how much, sir? 150 and D is 300 square upon 6. Sir, see, if I take what 300 by 6, this can be written as 150 into 300 into 300 into 300 by 6. So this will be equal to 50. And if you cancel here also 50, 50 cancel. So both are same. So here 1000 will be gone. 9, 10 power 3. 9.42 divided by 45. You will get a value of around 0.21. So this will be also 0.21. So the total value will be how much, sir? 0.42 Newton per mm square. Any doubt in this, students? Sir, Moinuddin, Momin Rashid, and also Vishal Ban. Can you please respond, Amma? Sir, eccentricity is 50. Yes. He has given in the problem, Amma. Sir, he has given clearly in the problem they are located at an eccentricity of 50 mm. Oh, no issue, no issue. Clear, sir?
150 into 300 क्यूब अपॉन 6 नहीं आएगा
150 into 300 square. Here d by 2 is there, Amma. This d will
ओके
cancel and this will
ओके सर
become d square. Okay, sir? Is it clear, Amma? So here, see student, I will tell you in a simple way. What is the stress at top? If you ask me, it is P by, sorry, if I give you an example, if the stress at bottom is how much, sir? The stress at bottom is load by area plus PE by ZB minus of MD plus ML. If you remember this equation, all the formulas will be sure, sir. Now see, if they ask you, they tell you that first case, concentric tendon. If I talk, they tell you concentric tendon means E will be zero. E will be zero. And also if they don't consider dead load and live load not considered, then in this case, E will be zero and dead load and not considered. Stress will be equal to load by area. Next case, eccentricity considered, but moment due to dead load, live load not considered. So here stress will be P by A plus P by Z. What is P? Load. And what is E, sir? E is nothing but the eccentricity. Clear, my dear students? Is this clear, Amma? Okay. Now see, students, we have a concept called pressure line.
दैट्स राइट सर
Can I move on? Okay. Next one we have is pressure line, or we call it as thrust line. Next one we have is what, sir? Pressure line or thrust line. What do you mean by pressure line or thrust line? See, sir, if you see, if you see here, if I consider here a tendon, okay, you will have a pre-stressing force here. Now see, sir, If you see what is pressure line or thrust line is, this is important number. The combined effect of the combined effect of the combined effect of pre-stressing force, the combined effect of the combined effect of pre-stressing force, the combined effect of pre-stressing force and the actual applied load. What's that? The combined effect of pre-stressing force and the actual applied load. The combined effect of pre-stressing force and the actual applied load will resolve into a will resolve into a will resolve into a single force. What's that? The combined effect of pre-stressing force. So here what I would like to tell you is the combined effect of pre-stressing force and the actual applied load, the combined effect of pre-stressing load and actual applied load will resolve into a single force. Okay. Now see the locus of these points. You can write the locus of points of the locus of points of the locus of points of resultant forces, the locus of points of resultant forces, the locus of point of resultant forces in a structure is termed as T line or thrust line or pressure line or whatever. Okay. Now see students, here there is a pre-stressing force here, and if you consider there is an applied load due to dead load or anything, so how this, if you consider this, it will be somewhere like this, sir. Means if you join this resultant, see sir, the locus of the resultant forces at a structure, you see this will look like a P line or a pressure line. And now see students, they can ask you, what is the shift in the P line or pressure line? The shift in the P line or pressure line at top or bottom is, if I take the section, this is important, Amma. This can be an objective question. If the depth of the beam is D, the shift of P line or pressure line, the shift of P line is very important. The shift of P line is D upon 6. The shift of P line is what, sir? D upon 6. You can write here. The shift of the P line or pressure line is D upon. This is equal to what, sir? This is equal to D upon 6. The shift of the pressure line is D upon 6. Sir, what is P line or? Yes, Mohammed Rashid, we have a sing. Sir, what I want to tell you is the locus of the why this shift occurs. Now see, sir, very good question. Now see, students, if we consider this here, now see, sir, if you have a pressure P line here, and if you have a P line here, what will be the moment? If you have C, what is the momentum? This is load and this is eccentricity. So if you consider anywhere, load and eccentricity will be P into E, right? So the moment will be same. But if you consider there is a live load or a dead load here. Now see what will be the load here. This load will be X. If you consider here, the load will be 2x. If you consider here, load will be 4x. So the load keeps on changing. So see, due to compression force, see this force, this might act about this point in an anti-clockwise, and due to this, it may act into another way. Now you are combining these two, and you are drawing the moment diagrams at that point due to that forces, or you are drawing the resultant forces at that point. So the resultant force keeps on changing with the load applied. So that is the reason, sir, actually the tendon will be something like parabolic. But here why there is a shift is because you are taking the both the combinations, and also the load is changing at every point. Simran Nazir, did I answer your question? Sir, load is always changing at every point. Now you can ask me, sir, what instead of that question, I thought that anyone why we want to study this P line? Why we want to why we want to study why we want to study why we want to study P line? Why we want to study is because that is why we want to study P line is, sir, P line because to understand the load transfer mechanism, to understand the not load transfer, load carrying mechanism, to understand the load carrying, to understand the load carrying, to understand the load carrying mechanism, we have done this. So why do we want to use P line is to understand the load carrying mechanism. So what is P line or pressure line? When the combined effect of the pre-stressing force and the actual applied load is resolved into a single force, then the locus of the point of the resultant force stresses or resultant forces in a structure is defined as a P line. Sir, see, when does this shift occurs? This is one of the question. Sir, the shift of the P line occurs when there is a change in bending moment. When there is a change in bending moment, there is a change in bending moment, Amma. Definitely there will be a change in resultant force. When there is a change in bending moment, there will be a change in when there is a change in bending moment, there will be a change in resultant force. Sir, see students. Now, see, students, what I would like to tell you is if there is a what is the shift? Why we are want to understand the shift of the P line is when there is a change in bending moment, there will be a change in the result of resultant force. So when these are going to change, definitely there will be a shift in the P line. Yes, yes, very good, Sudhanshu. That's what I told you. You can write pressure line, P line, or thrust line, everything is same. Everything, P line, pressure line, thrust line, everything is same. Everything is same. Yes, Sudhanshu. Okay, just go through this, Amma. I'll be back in 5 minutes. And after this, we have to discuss the most important topic also. Just go through this slide. I'll be back in 5 minutes. Chilling. Now see, this is the pressure line or thrust line. Sir, another important point they can ask you here is the load balancing concept. If you see, I'm seeing a lot of questions in JE or AE related to load balancing concept. Sir, see, what is load balancing concept? We'll understand first. First, we'll understand what is load balancing concept. Sir, here in the name itself, the load balancing concept. What do you mean by load balancing concept? Is the load is balanced here. Okay, load balancing concept means load is balanced. Now you'll ask me how this load is balanced. Now see, sir, you can say the load due to the load due to dead load, live load, or you can say the load is balanced by the. You can say in this way, the load is balanced by the load is balanced by the. I'll show you, sir. Don't worry. The load is balanced by the moment due to pre-stressing force. Sir, see, suppose if you have a section here, and if we consider this as a neutral axis, we have a pre-stressing force here. We have a pre-stressing force here, and this is a tendon. This is what, sir? This is a tendon. So here it is P, and here it is eccentricity. It is a. So here it is moment is equal to what, sir? Here moment is equal to load into eccentricity. So if I consider what is eccentricity means m by p. Okay, eccentricity is equal to m by p. Suppose if they give you the tendon is parabolic, if they give you the tendon is parabolic. Sir, in case of tendon parabolic, see, if I consider a simply supported beam, if we consider a UDL loading, in that case only the bending moment will be equal to what, sir? The bending moment will be parabolic. And what will the bending moment at center? It will be equal to WL square by 8. So here what will the eccentricity? Eccentricity will be equal to WL square by 8P. Because whatever the moment which is occurring due to dead load is WL square by 8. And what is the moment due to pre-stressing force is load into eccentricity. So you can write eccentricity is equal to WL square by P. Suppose if they give you the tendon is triangular, can you tell me what is the answer? The tendon is triangular. What will be the balance eccentrical loading or what is the eccentricity? If the load is triangular, I'll give you 2 minutes, sir. I'll give you a minute. If the tendon is triangular, what is the eccentricity? Sir, it is very easy, Amma, if you know the concept. Very good, Vishal Baba. Very good, sir. Sir, see, if you consider a simply supported beam, okay, if the load is at the center, you know the maximum bending moment is how much, sir? It is WL by 4. So eccentricity will be equal to WL by 4P. So here you should know the bending moment diagrams. If you don't know the bending, because what is WL by 4? WL by 4 is the moment due to this is the moment due to dead load, moment due to load. And what is P into E? This is the pre-stressing force. So when they both are balanced, what I want to tell you here is, suppose C student, if I consider here a pre-stressor concrete beam, you will have a load here. This is dead load or live load or whatever load. due to this load, there will be a moment, and this moment will act somewhere here like this. Now, if I see here, there is a tendon here, and this is pre-stressing force. And if I consider this as neutral axis, this will be okay. So here this will be load into eccentricity. So whatever the load into eccentricity should be equal to the moment. So this is the moment due to the load, and this is the moment due to pre-stressing force. When both are equal, what will be the eccentricity? That is called load balancing concept. Clear, students? Rohit, is this clear? Amma? Now see, students, here we have talking about parabolic and we have talking about triangular. Suppose if there is a trapezoidal tendon, somewhere like this. So please solve this. Tendon is trapezoidal. What is trapezoidal tendon? 8:30. Now see, students, anyone, can you tell me? Sir, see, if we consider a simply supported beam, usually we have a supported load L by 3 and L by 3. The bending moment diagram will be like this, right? This is trapezoid. So what will be this value? This value will be equal to WL by 3. So here eccentricity will be equal to W upon 3P. Sir, for this is how. Sir, for your information, how to solve bending moment and shear force, I will give you an example, Amma. Suppose here if this is a load W, and here we have A, C, and B. First you say how to solve is reaction at A plus reaction at B. Upward force is equal to downward force. Reaction plus A plus B is equal to what's a load. And what is this length? This is the length of the beam. This is equal to what's a this is equal to the length of the beam. Now see, students, what I would like to tell you here is at simply simulated at any of the supports it will be 0. So if I consider moment at B is equal to 0, this will be RA into L. That means this is acting down, means clockwise. So RA into L minus due to force, due to load, it will be minus W into L by 2. So if is equal to 0, if you solve this, RA will be equal to W by 2. If I substitute here W by 2 plus RB is equal to W. So RB is equal to W by 2, RA is equal to W by 2. Now see, students, if I consider a simply supported beam, this is W by 2 and this is also W by 2. Now, how the shear, now if I take a section at here, something here, what will be the bending moment at a section X? It will be equal to this load W by 2. What is momentum? Force into distance minus W into X minus L by 2. Now see, sir, for bending moment to be maximum, the shear force should be 0. What is shear force if you see? RA minus What will be the shear force? Where it will be the shear force maximum? So suppose if I take it a section X, you can say here there is no load. The shear force will be max at center. So if I substitute here at X is equal to L by 2, at X is equal to L by 2, the shear force is maximum. So moment is equal to W by 2 into L by 2. That will be equal to how much, sir? WL by 4. Clear, sir? So this is how we have to calculate the bending moment at a section. This is how we have to calculate the bending moment at a section. Now see students, is it clear? Now similarly, if you want to talk about the UDL loading, if you want to talk about UDL loading, if there is a simply supported beam having UDL, if this is a simply supported beam having a UDL, sir, see, if I consider here a section X, now total load will be how much, sir? This is L, this is W per meter. So from symmetry, total load will be equal to how much, sir? From symmetry, total load will be equal to how much? From symmetry, total load is equal to W into L. So from symmetry, it will be WL by 2, and this will be also WL by 2. If I write the shear force will be equal to WL by 2 minus WX. So for bending moment to be maximum, the shear force should be 0. So shear force is WL by 2 minus WX is equal to 0. So here you can write at X is equal to L by 2, bending moment is maximum. At X is equal to L by 2, bending moment is maximum. Now how do you write bending moment, sir, here? How do you write the bending moment equation? You can write WL by 2, suppose at this X minus, what is the total load? This is X, and it is supposed to act at center, minus W into X is the total load into moment is X by 2. So if I substitute here L by 2, WL by 2 into L by 2 minus W into L by 2 into L by 2 by 2. So this will be equal to WL by square by 4 minus WL square by 8. That will be equal to how much, sir? WL square by 8. So actually you should know all these concepts before solving the problem of balanced section. Clear, sir? Now, if you consider in, sir, this is also important, they can ask you. You can say design classification of, design classification of, design classification of, design classification of pre-stressed members. Design classification of pre-stressed members. What is the design classification of pre-stressed members? If I talk about type 1, if I talk about type 1, you can write here, there are no tensile stresses. In type 1, what's it? There are no, sir, if they give you in pre-stressed concrete, type 1 design means there are no tensile stresses. When I talk about type 2, when I talk about type 2 means tensile stresses are allowed. If we talk about type 2 means Tensile stresses are allowed. Here you can write tensile stresses are allowed, but no visible cracking. No visible. So here what is type 2 is tensile stresses are allowed, but no visible cracking. Next one we have is type 3. What is type 3 is cracking is allowed. Type 3 is cracking is allowed, but should not affect the durability. Cracking is allowed, but it should not affect durability means age. Sir, directly they will ask you if this is a structure where having tensile stresses, it comes under which type. You should know all these things, but should not affect durability. So here what I would like to tell you here is the limits of the crack width. Crack width cannot be more than should not be more than 0.2 mm, or it should not be more than 0.1 mm in case of aggressive environments. So here what is type 1 is no tensile stresses. Type 2 is tensile stresses are allowed and no visible cracking. And type 3 is cracking is allowed, but it should not affect the durability. But it should not affect the what is type 1, sir? No tensile stresses. Type 2 is tensile stresses are allowed and no visible cracking. And what is type 3 is cracking is allowed but should not affect the durability. But should not affect the durability. So these are the design classifications of prestressed members. Back slides.
सर एग्रेसिव क्या क्या लिखा है?
Sir, aggressive means in marine structure, sorry, in case of marine or sea, the environment will be more, means there will be more chances of failure. इसलिए उसमें कम है, उसका ज्यादा भिड़ते तो बहुत बहुत मुश्किल होता है, इसलिए उधर थोड़ा कम है. इमरान लोई, which slide sir? This slide, this slide. Next. Okay sir. I'll give you one question, some more objective questions in this. The first objective question is the mass production in railway sleepers. The mass production in railway sleepers. Mass production in railway sleepers. Mass productions in railway sleepers. Mass production in railway sleepers can be done with mass production railway sleepers can be done with can anyone tell me, sir, what is the mass production in railway sleepers can be done? I've told you already. Mass production in railway sleepers can be done with Hoyer's method. I told you already, Amma. Similarly, if they ask you circular pre-stressing for water tank, circular pre-stressing, circular pre-stressing, circular pre-stressing for water tanks, circular pre-stressing for water tanks can be achieved by the circular pre-stressing for water tanks can be achieved by preload method. Can be achieved by what, sir? Preload method. Circular pre-stressing for water tank is achieved by what, sir? Preload. Sir, you know what is the minimum grade for pre-tensioning? M40. And the minimum grade for post-tensioning is M30, right? Sir, I'll give you one simple question which I have told you already. The profile of the centroid, the profile of the centroid, the profile of the centroid of the tendon, the profile of the centroid of the tendon is, the profile of the centroid of the tendon is parabolic. The profile of the centroid of the tendon is, the profile of the centroid of the tendon is parabolic with a central dip, with a central dip, with a central dip pre-stressing force P and length L. What is P, sir? Pre-stressing force and L is length. What is the equivalent? What is the equivalent upward? What is the equivalent upward acting uniform load? What is the equivalent upward acting uniform load? What is the equivalent upward acting uniform load? Can I solve this problem, students? Very good, sir. See here. Actually, if you see the concept, Amma, if you see the concept here, it is simple. Sir, see, you know already, moment is given as load into eccentricity. This is due to pre-stressing force. And moment due to load is given by what, sir? See, the profile at the center of the tendon is parabolic with a central dip H. Okay. So here, instead of moment, you can write it as P into H is equal to, what is the load he is telling? The load will be equal to what, sir? WL square by 8. Because it is a parabolic. Now see, sir, P into H is equal to WL square by 8. So he's asking what is this W? So you can write it as W is equal to what is uniform acting load, he's asking. So 8 pH upon L square. 8 pH upon what, sir? Clear, students? Is this clear, Amma? Now see, students, I'll give you another question also. The another objective question is, sir, please don't miss tomorrow's class, Amma. In tomorrow's class, definitely you can inform your friends also. In tomorrow's class, you'll get definitely one question. The question here is the use of curved cables. The use of curved cables in a long span. The use of curved cables in a long span. The use of curved cables in a long span. Prestressed members. The use of curved cables in a long span. Prestressed members. What does this will do is this will reduce the bending moment at the curved cables will reduce the bending moment at supports. This is very important now. The use of curved cables reduces the bending moment at where, sir? This try to reduce the bending moment at the this will try to reduce the bending moment at the supports. So this is what we have discussed today related to the analysis. So here I'll quickly go through these things, Amma. Second. So if you talk about the analysis, concrete is a homogeneous material. Concrete and steel behave elastically. Bernoulli's assumption is valid strain, and this is the how the stress due to direct load, or if this is the stress due to load and eccentricity, and this is the stress due to load, eccentricity, as well as moment due to dead load and live load. And we have done one problem, and this is how P line, or it is a combined effect of pre-stressing force and the actual applied load will resolve into a single force. The locus of these points is nothing but P line, pressure line, or thrust line. Okay, here P line or thrust line or anything is to understand the load carrying mechanism. Here we have a trapezoidal tendon, and this is design classification of pre-stressed beams is type 1 no tensile stresses, type 2 tensile stresses are allowed and no visible cracking, and type 3 is cracking is allowed but should not affect the durability. Okay. And circular pre-stressing can be achieved by preload method, and mass production in railway shapers is achieved by Hoover's method. Sir, pre-stressed for Mohammed Rashid. I want to tell you, if you are using post tension, that is for longer spans. If you are using pre-stressed for shorter spans, then you will go with pre-tension. Clear, sir? Post for long, because if you see bridges and all, it can be 1 kilometer or 2 kilometers. Then huge spans will be there. For that case, you will be going with post tensioning, and for smaller spans, you will be going with pre-tension. Like railway sleepers, you will be going with pre-tension. Sir, is this clear for everyone? Sir, breaking of wires concept, I am not told. Breaking of wires should not exceed 2.5. That concept tomorrow I will be telling you. Last slide. Long span pretension. I didn't get it. Muhammad Rashid, usually they see practical, sir, problematic, they can give you anything, but in last slide, please. This slide you are asking. See, what I would like to tell you, Mohammed Rajid, is I've shown the last slide, right? This is the last slide. Okay. Sir, with this, we are done with the today's class. And any doubts you can ask me, Amma. PDF I'm sent. Yesterday I've sent you Shahid sir. I'll be sending you PDF immediately, Amma. Okay. Don't worry about that. Okay, with this we are done for the day. Sir, another important thing I would like to tell you, whenever you are practicing JE or AE, you have to first to be clear with the concept and then try to solve as many objective questions as you can. Sir, first and foremost thing what I no. Cables usually follow parabolic only, Imran only. Cables usually for simple case they will only follow parabolic. Usually. And one more important thing, students, what I would like to tell you is that in case of simply supported, sometimes they can follow, but in general, we are talking about parabolic only. Sir, one thing I would like to tell you, if anyone is having objective kind of books, once you are done with the concepts, try to solve as many previous questions as you can. Suppose if you are writing HPSC, write as many questions as you can from HPSC and JKSC and see the pattern, sir. In 2022 in HPSC, they have given all the objective questions of direct gate. Sir, in JKSSB also, I'll tell you, you please go through the objective questions of IES as well as gate, sir. And also you can see the concepts. Then definitely these points will help you, sir. Okay, sure. Mohammed Rashid, I'll do that, sir. Okay, I'll do that. Sir, in one of the exams, they have given directly the questions of previous gate questions. Okay, with this we are done, Amma. Thank you for attending the session. We'll see you tomorrow. Have a nice day. All the best. Thank you. Bye bye. Have a great day. Bye bye.